Hi, I'm Herkko, Plit, founder and CEO of P2X Solutions there. I've been working 30 years in the energy sector there and the various roles constructing large energy infra like Baltic Connect, for example, then the opening Finnish gas market and etc. Then also some years in the public sector, in the ministry and in the European Commission. And that provides me a good opportunity to tell you there about then the alternative fuels there and how the energy sector will change in the coming years there. And I want to start there with this picture then, which is showing now there that whenever we are making choices for our next car, I think many of you have considered not to buy any more diesel or gasoline fueled car. Instead, you are considering hybrid, electric there. Maybe some people are considering even to buying a hydrogen car there. Actually, the car in the picture is a Hyundai Nexo there, so which is a hydrogen car. However, the message what I'm saying there, that we are in our daily lives already considering our lives then, which would be then something else than based on the fossil fuels there or fossil products. And about that I'm going to tell you there in my speech there, how we see there that the world is changing. And before jumping into that topic, then I think it's very important that we are understanding then what are the largest challenges there, why the change is taking place in the energy sector there. So the largest challenges are really the distribution and the storage of energy there, And we have used to distribute the energy then via electric cables there, so to say you see wherever you're going there, the electric network is existing. However, in the future, I can say there that the way of energy is transferred is not only based on electricity, it's also based on the molecules. We are already having gas pipe networks there, but in the future we will have hydrogen pipe networks. And that's the reason is there that actually they are much more efficient than the electricity network there, so to say. If you are having this one of the largest then, so to say, electricity distribution networks, which we're having 400 kV then it's called in Finland, you've certainly seen those then when looking again or driving around in the country. The same amount of energy can be transferred then, so to say, by very small gas pipeline. Or the other way around, if you have one diameter gas pipeline, transfers same amount of energy as 14 of these 400 kV electricity distribution lines there. So much more energy density is involved over there. The other issue is the storage, because we will produce more and more about our energy in intermittent way there, meaning that renewables, solar, wind, hydro. We have to be able to store that energy, because when we cannot be weather dependent so much, then when the sun doesn't shine, wind doesn't blow, we have to have also capability to have the electricity available there. So those two drivers are the main ones then which will, so to say, which we have to solve then in the future. The other issue is there, the politics enables the change. And whenever there's a large change there needs to be kind of the right momentum that to happen. And if you're looking now what has happened in the European scale, and even on a global scale there has been much of these regulation issues then. Are we talking about Green Deal there then in the European level there? Despite we are having now the new commission, they are driving and saying the green transition will take place there. Also in the so to say United Nations level then, these COP meetings there is the one which we had in Dubai last year there was a clear signal. We have to get rid of the fossils, and the regulation will make that happen. And that will mean there that we will have a price for the coal. We have this emission trading system already existing, and whatever, so to say, in the future you will buy, I can say you then will have a price. Whether that happens in 2 years' time or 5 years' time, but in the future this will take place there. So whenever you go and buy a bread, for example, you can have a label then which is saying there, this is the price for CO2 or for the coal in that bread, And then the customer can make a choice there. Do I want to buy a higher product there, so to say, higher price or with this fossil content, or do I want to go for the, so to say, sustainable solution where there's no high carbon used and so forth there. And actually, then when the carbon will have a price, it will drive the market of the non-fossil products then developing faster then. So the kind of price parity then, when at the moment the new sustainable non-fossil products, they are much higher priced than the fossil alternatives there. But when the carbon will have a price, then this price parity comes quite quickly there. And this is something there is that together with this politics and this that the carbon will have a price will influence that actually the change will take place quite soon there, sooner than we are expected there. And that's why we have to now go forward and understand what's going to happen there. And first we have to understand there where the alternative fuels are produced. We have to have first of all the right sources for that one there. And then we are talking about hydrogen. And the first issue when we are talking about hydrogen then, that we want to have the hydrogen is also cleanly produced. And we are talking about green hydrogen. There are several colors that the hydrogen is having there. And typically it's kind of gray, which is then produced from the gas. It's a fossil product. But when we are talking about these alternative fuels, we're jumping into the green hydrogen business. Clean hydrogen also in other terms there. And that means there that we have to have this renewable energy that we are producing electricity over there, being it solar or being wind. Actually, I can state you there that there's marriage between the renewables and the hydrogen is inevitable. The both need each other there. And justifying that one is over there that when we are producing these more and more renewables, especially in Finland, we are having lots of this wind power. More and more solar is also coming into the picture there. But we have now noticed there that there has to be also consumption, because the wind power producers don't develop their further electricity production if they don't have enough consumption. So they need to have this new kind of consumption, which is coming through the data centers there, the batteries, and also hydrogen units there. And therefore, so to say, the wind producers need also the hydrogen. Now, another issue is as well there, because when it doesn't blow or so, then the prices are quite low and the consumption in the hydrogen units in those days can be utilized. So in turn, the hydrogen producers are benefiting then from the lower prices, because then they can get the cheaper hydrogen on that one there. So that's why the kind of marriage is over there. The both needs each other there, and the other one doesn't take place there if the other one is not over there. And this is very easily forgotten there. We are talking about the renewables there, but the renewables really need to have some party with them. And on the other term there, to develop this hydrogen market forward, needs to have that story as well there. And here's an example there, so to say, it's 2 years ago there, but it's a very good example, because when we're having then 4 gigawatts of wind power production in our country there, we can say there that in a normal summer day, then the consumption power is something like then, so to say, 10 gigawatts there. So it's not even half of our country's production portfolio. But this 4 gigawatts already was influencing quite much on our power level. When the wind blowed, price was coming down, and when there was no wind, the price were coming up there. And now people are saying that the future is more renewables, because we want to get rid of the fossil fuels there. That means that we are replacing it with renewable power. It means there that more and more of this intermittent power comes into the market. Volatility up and down increases. The power of that volatility then will be much higher than that is actually shown in this picture. We have already experienced there that we have prices over 1,000 euro per megawatt hour and so there. I think nowadays every Finn at least has been looking very carefully then what is the electricity prices then, because this is of the reason there of this volatile market. And this change will increase much more in the future there, and we have to somehow balance it. And hydrogen is one way of doing it then. We have also then these batteries, they are extremely good examples there, and then there are pump storages and so forth there. All these kind of sources are needed, but when we are talking about large scale there, so talking about gigawatts then, so gigawatt is 1,000 megawatts there, and 1 megawatt is 1,000 kilowatts, so large quantities, then we need to have also somehow the hydrogen involved in the business then. And now we are starting talking about then also when the alternative fuels are coming up. But first we are having this wind and solar power production. Then we are having this hydro molecule is there, this HO2 there. We are splitting the water molecule then into two parts, then H2, hydrogen, O2, then oxygen there. And that, so to say, method, how it's and the equipment where it's done, it's called electrolyzers there. And quite simple then, and we do that the electricity is splitting that water molecule over there. So now we are having the hydrogen available. We can either use this hydrogen directly in the industrial use, we can store it, but when we are talking about now the fuels, then we are taking the next component, which is the CO2. We have in Finland lots of these factories, power plants, which are emitting CO2 to the sky. Instead of letting go, we are capturing it. And now we have then ingredients for the alternative fuels there, so to say. We have the hydrogen, and then we have the CO2. So blending those together, we can make synthetic fuels like e-methane there or e-methanol. And this is really there where the future lies there, that we need to replace those fuels then, so to say. At the moment we are utilizing diesel, gasoline and so forth there. Let's start with the road traffic over there. There we have already some gas trucks which are operating there. But in the future, talking about heavy duty traffic first of all there, so to say, the future will be electric as well there. Electric traffic is something there that we are already having with the passenger vehicles, and some electric trucks will be there. However, because there are long distances and so much power needed by the trucks, they cannot only be battery driven there, hydrogen trucks will become a future as well there. And especially in Finland then, so when we're having long distances there and scarce networks, we cannot load these lots of megawatts then, so to say, in one place all over there. So therefore, so to say, this hydrogen, you simply plug in the hydrogen pump, then fill it 20 minutes and then you go off there and you don't have to wait such a long loading times over there. That's one way coming it up then. Then, so to say, hydrogen can be also utilized then in short distance maritime ferries, for example. If you have been in Archipelago of Turku, for example, there is now already then, so to say, solar-powered ferry called Electra, and so to say, which is going from Parainen to Nauvo, 10 minutes. Battery is enough there, so to say, because distance is low. But if you continue the journey from Nauvo to actually Skorpo then and Hutsa, there's a 30 minutes ferry trip. Over there, actually, the batteries are not enough because the machines are so powerful there, so you have to have something else. Then if you want to traffic it on non-fossil way, there hydrogen can play a very good, so to say, fuel sources over there. When we are talking about then distances going longer in the maritime sector, then we are starting talking about the e-methane there or e-methanol and also ammonia. Ammonia is also something which is produced then from the hydrogen sources there, and that means there that we have this H2 there, but then we actually capture nitrogen from the air, and that we can utilize to produce then the E-ammonia. But if we go now for this maritime, we are already having LNG ships. Some of you might have been cruising there with from Turku to Stockholm with Viking Grace there, or Megastar from Helsinki to Tallinn. They are LNG ships, and they can easily be replaced by this e-methane there. No fossil fuels anymore on those ships if they so want. On the other hand, then e-methanol and e-ammonia are the sources that can be utilized in the ocean-wide traffic there, because you have to have large energy density there and to be able to store it there. Therefore, hydrogen or e-methane are not suitable for longer distances. When you are going from Europe to Americas there or Africa and so forth, these longer distances are needing these different fuels then. And there, it's an interesting competition how it will be in e-methanol or e-ammonia. Either of those will be then used anyway. Then my tip is there that e-methanol will be a winning concept then, and the reasoning for that one is there because it's non-poisonous there and it's easy to handle there. And if you look at in the past there, what kind of fuels have been, so to say, the winning ones there. So today's petrol or gasoline, which we are using, easy to handle, easy to tank. And that's why I'm tipping on the e-methanol also over there. Then we are having aviation there. Also there, first electric, so to say, airplanes have been already flying there. The same has happened with the hydrogen. So for short distances, those are then, so to say, suitable fuels there. But when we are going for longer distances, then we need to develop the kind of e-kerosene, or we are talking about e-SAF, e-sustainable aviation fuel there. And that is once again then, so to say, normally it's produced that you are having this green hydrogen, which you take, then capture the CO2 once again, make the e-methanol, and from the e-methanol you can then produce then the e-SAF production. For example, in Finland, then we have a company called Neste who is, so to say, willing to develop this e-SAF there. And our, so to say, company's value chain is there that we can produce this e-methanol, and that is further than utilized in the reprocessing of this e-SAF over there. And interesting issue on those is there that the quantities which we are needing, talking about maritime or so to say aviation, we are covering almost like 10% of the global emissions. So the potential we can save the emissions globally, replacing there, so to say, the traditional fossil fuels with this e-SAF, e-methane there, e-methanol is immense. And that's why it's so important there that these alternative fuels are discussed. The potential with these alternative fuels is immense there, and actually, so to say, Goldman Sachs has made an estimation there that what will be the hydrogen economy. It will cover then the, so to say, the production of these alternative fuels, but also then the use of hydrogen in the industrial sector there. But it would be then, so to say, 1/4 of the whole energy sector then. If you imagine then how much oil we are using today there, in 2050, 1/4 would be hydrogen-based there, so to say. And the market value would be 10,000 billion euros there. So 10,000 billion euros then. It's immense market we are talking about. That was also the reason I set up the company, because if that's a market potential is there, something would be also then for P2X to gain on that market. But very, very important there is there that how this market develops there, and there's already a regulation placed in the European level there that in the maritime sector, for example, there's a 2% kind of blending mandate needs to be there. It means that next year onwards there, the cargo companies or whoever is operating the maritime vessels there, they need to have 2% of these synthetic fuels there, or the e-fuels, e-methane or e-methanol or ammonia in their portfolio. The regulation forces us to change into that one. And that has been very traditional, and then so to say, when the new market development is taking place. Then when we are looking at the wind power there, so there was forced and supports on those ones there, and then the market took up really. And the same is really foreseen now here there, that the regulation forces the companies to go on that one, because now those non-fossil sources are more expensive than the fossil alternatives there, and that limits, of course, the companies to jumping into that one, because only being sustainable there is a good issue then, but still a traditional business prohibits some companies going for that one, and this mandate then gets those fuels into the market, which in turn then accelerates their production cost, and they are coming cheaper in the long run there. The other one is there the aviation sector there, which is also having its mandate until 2030. There will be then also, so to say, huge amounts of these non-fossil or synthetic fuels which are needed in the market. And why we are in Finland talking about this? Not only because we are interested in sustainability issues, but this is lifetime chance that Finland has to boost its economy. We are talking about, let's assume we would have a card game here, so we are playing a poker there, and actually we are having in this game 4 aces. One is there that we have a huge amount of renewable we can produce in our country, and its price is cheap in the European context, because electricity is the main driver over the cost of the hydrogen and the alternative fuels there. If we have cheap electricity, we are good. The other one is there that we are having this CO2. As said, the alternative fuels are needing this, capturing the CO2. We are having our pulp and paper factories here, and many biomass power plants and so forth there. Finland and Sweden are uniquely positioned in the European scale there, that we are having these millions of tons of sources of this CO2 which we can emit over there. And now we can take that capture and utilize it for the alternative use there. Third one is there that very stable grid, because this electricity needed when we are producing this hydrogen. And the fourth one is there that we are having lots of this clean water. Our lakes are extremely good there. We don't have to desalinate or so, which would be needed, for example, in the Middle East there and so forth there. So Finland is very well placed on that one there. So in that respect, we have great chances to develop those issues. And in our, so to say, company, P2X Solutions, we have started this journey. Because this is not an overnight story then. It takes 4 years to develop from a plan to an actual production. And when we are saying and talking out there that we have to have something ready then by 2030 or 2025, companies are thinking of 1 year ahead. But we have to think about 4 or 5 years ahead then, because then the actual production will start lately. And therefore, so to say, we are having now Harjavalta. We are constructing and getting it in operation this year, the first 20 megawatt green hydrogen production unit then. And we will also produce there the first portfolio of these synthetic fuels, namely e-methane there. We can replace then the Russian gas which used to come to Finland there, and also that can be utilized in the maritime or even road traffic sector. First, e-fuels are coming into the market. Our next unit would be in Joensuu there. We are doubling the size, increasing it there, and they will be producing e-methanol there, and that would be go as it now looks like mainly for the maritime sector. Then our next project is in Oulu, 100 megawatts, and there we are scaling it up there, that our plan is to build 1 gigawatt by 2031 there. By the way, Finland's target is to produce 10% of the European green hydrogen production there, and of course then the portfolio taking there in the synthetic fuels there is immense there, so we can consider that being even larger because of this unique CO2, biogenic CO2 that we are having in our country there. So we have a vision, we have concrete actions taken there, and something which we always have to remember is there, when we are doing a change, it's people's business. we are doing this together. And each and everybody needs to be involved there, that we have to believe in this change and make it to happen. In such a way there, we can also create a sustainable future for our children and for the future generations. We can, so to say, the world cleaner together. Thank you.
Welcome everyone. On my behalf, I'm Jaakko Niukkala, and today we'll be talking about new energy solutions. And first, a little bit about myself. So I work as a smart product specialist at TT Gaskets, and I have been working for TT for the past 6 years full time, and before that as a summer trainee since 2010. And my background is I'm a Master of Science in Electrical Engineering, so I have a strong technical background, and my role is to develop products and services for the future. And in my pastime, I'm a big football enthusiast, and I also love to renovate my home, so those two things fulfill my pastime. And today we'll be talking briefly about TT Gaskets, so a couple of slides about that. Then we'll be presenting our current public new energy development projects with academia and research institutes. And then to the sealing part of the presentation, so challenges and solutions briefly. First, a couple of numbers about TT Gaskets. So we are a well-established startup, over 80 years of experience in sealing. So annual revenue is roughly 21 million euros, and there's 100 of us. And we are heavily globalizing currently, so there's four destinations where we are at. So in Finland we have the headquarters, then 2 sales offices in Sweden, 1 in Germany, and one agent in China. So, and we are doing exports to roughly 50 countries. And we have strong experience all around all industries. So automotive industry is basically the only one that we don't support, and everything else we have our hands on, so there's plenty of experience. Public new energy projects we are currently working on, so a couple of words about those. So first, we have been doing cooperation with the Lappeenranta University of Technology. So they have a strong energy research field there. So we are working with them in the development of alkaline electrolysis. So we have a couple of projects going there. We are in the steering group of this green hydrogen from research to stack production project. And the purpose for the cooperation is to develop our skills in these fuel cell solutions, trying to find better solutions to the currently available ones, and trying to partner with the other members of the steering group, and of course trying to reach for a commercializable solution for the alkaline electrolysis. Then we are also working locally with the Tampere University of Applied Sciences. So there we have the couple of projects going on. The first one is regards this electrolysis testing environment. So they are building their own electrolyzer environment there to test how they behave under variable loads, and there we are trying to find better solutions for the currently available sealings and gaskets. And the other project we are working on regards the hydrogen safety. So that's of course an important part. Then hydrogen is a dangerous gas, so we want to make sure that everything is safe and according to standards. And that purpose of those projects is again trying to find find better alternatives, find new knowledge for the sealing parts, and study how they behave under stress and age during variable loads. And then, of course, we try to influence the safety requirements, try to work on those to make better standards, better instructions for these hydrogen plants that are built all around Finland and all across the world. Then we are also working with the Technical Research Center of Finland, VTT. So they have these future fuel testing facilities there, and we are working with them in cooperation with our clients to find better solutions for these new fuels, methanol, ammonia, hydrogen. So, and of course, to find mutual projects to develop those energy sources in engine use. Then we are also working with Aalto University. They have also these future fuel related projects, and the hydrogen project we are currently working on is regarding the hydrogen value chain in total. So how to simulate that and parts of that value chain. And there, of course, our role is to develop the sealing solutions suitable, for example, for compressors that are needed in all around the value chain. And then last of these partners we have is Mission Hydrogen. So it's a European future fuel and hydrogen knowledge sharing platform that we are part of, and we are having a webinar there in autumn. So in September you can join that also to find Mission Hydrogen website, and that part of the cooperation is of course to know the players in Europe regarding the hydrogen world and try to find the best partners for us. Let's hop into the most important part of the webinar, so the challenges and solutions regarding these new fuel and new energy systems. So of course hydrogen is a hot topic. It's discussed all around media that when the hydrogen economy will become reality. But of course hydrogen has been used for decades already in the process industry. So the gray hydrogen made from fossil fuels is a common part of for example chemical industry, and despite its reputation, it's not impossible to seal. Of course it's difficult. The circumstances need to be right, and the flanges need to be designed for hydrogen use. But of course it is doable. So but in these new hydrogen applications in the new energy sector, it is more troublesome, because in all cases we cannot use standard flanges. So for example, if we want to replace LNG with hydrogen in these engines, we cannot use standard flanges all around the engine, because, well, that's just impossible. So of course that sets some restrictions to the sealing solutions we can use. So the flanges are irregular, they are thinner, there may be less bolts available, so the bolt loads are lower and not that even as in standard flanges. So it's more difficult to seal the hydrogen properly. Then there are phenomena that are of course unknown also in the process industry, in the like standard flange world, like hydrogen embrittlement, which still causes issues after decades. But in the engine use, for example, there are more phenomena that are not that well known, that are not like publicly or public information. So they are in the company that makes the engines only know this and that. So that sets issues with the sealing. But of course, most of the challenges are doable, but we have to set for something at this point and develop as the hydrogen engines progress, for example. So currently the suitable solutions with hydrogen are fiber and graphite gaskets that can be used in some cases when the circumstances are right, not that high pressure, not that high temperature, for example. Then semi-metallic and spiral wound gaskets, of course, they are used in the process industry world, but those can be used in some cases with the new energy solutions as well. And then metallic gaskets are also suitable for hydrogen use. Then the hydrogen derivatives, so methanol and ammonia, those are the two kings that are discussed, for example, in the engine industry. So both of those chemicals, they are common ingredients in the chemical industry. So sealing methanol or ammonia is again not impossible. They of course have their own tricks. You need to know what kind of sealing solutions you can use. But the biggest issue with these chemicals is the compatibility of the material for these two. So of course currently the engines don't run on pure methanol or pure ammonia. They are dual fuel systems, so they run both on diesel and then methanol. Basically a couple of engines maybe on ammonia already, but mostly they are run on diesel. But when you switch the fuel to methanol, for example, you want to make sure that the components around the engines can withstand methanol, and that's not always that easy to find materials that are suitable both with diesel and methanol or ammonia. So one example of this is NBR, or nitrile rubber, that is widely used with fossil fuels. It's oil resistant, so that's a natural choice with diesel engines, but that doesn't withstand methanol, for example, at all. So it wouldn't be feasible for the ship operator to change all the gaskets around the engine when they want to switch from diesel to methanol. So that's why we want to make sure that the materials we use are chemically compatible. And suitable solutions for methanol and ammonia are, for example, PTFE materials that can be used in low temperatures, so temperatures below 250 degrees. Then graphite material, those are widely available and chemically compatible with both methanol and ammonia. And then metallic gaskets are also a possibility. Then a couple of words about fuel cells. So we are currently working with all of these big three technologies. They all have their unique properties that need to be taken care of when designing the sealing solutions. We could say that alkali and PEM, or proton exchange membrane fuel cells, are quite similar in operation and operation conditions. So they are low pressure, low temperature, so roughly 100 degrees and a couple of bars usually. So it sounds that it's not that difficult to seal, but the issue with these two fuel cell types is that low bolt load available. So when we compress the stack, we cannot compress it too much, because then the fuel cell stops working, and well, that's probably not something we want to see when running a fuel cell. So we have to find suitable sealing solutions that have good sealability already at low bolt loads, and those include, for example, EPDM rubber, which we have been used successfully, and then printed seals, for example epoxy, that can be printed on multiple base materials. And then we have also made a couple of stack redesigns to improve the sealability and make the end product more cost efficient. So that's also a possibility if we can make changes to the stack design. And then the solid oxide fuel cell, that differs completely from the alkaline PEM regarding the circumstances in the fuel cell. So it's usually high pressure, or at least higher pressure than in alkaline PEM. And then the temperature is a lot higher, so we are talking about 600 to 700 degrees in operation. So that really sets challenges to the stack durability due to the high temperature. So there are not that many materials that can withstand such high temperatures. So we basically use mineral-based materials in those cases, such as vermiculite and mica. We have, for example, our own brand MicaSeal Suniflex that can be used in some parts of the cell. And of course, we have other vermiculite-based materials that are widely used in the stacks, for example. And then we can use standard-sized spiral wound gaskets and cam profile gaskets with possibly mineral facings to withstand the high temperature. And then last but not least are batteries. So the difference between batteries and all of the other new energy systems discussed here is that usually in batteries and powertrains we want to make sure that the outer world doesn't come inside the battery pack or the powertrain, but in, for example, engine applications, we want to make sure that no oil or ammonia gets to leak away from the engine. So the battery seals are a bit different in that sense. And usually the seals also have multiple purposes, so they don't just make the battery pack or powertrain weather or dust proof. They can also insulate heat or electricity, or in some cases they need to conduct heat or electricity at some level to make sure that the battery pack operates and there's no safety hazards involved. And then the suitable solutions for batteries are, for example, silicones and polyurethanes, really soft materials that seal at low surface stress available at the battery pack. Then if we need some other purpose than just to seal it, we used these multi-layered composites or rubber corks with different layers that can either insulate or conduct depending on the end use. And then of course graphite and mineral materials are also suitable. So we have made, for example, a graphite gasket that conducts electricity to make sure that no electromagnetic radiation can get into the battery pack. So those couple of examples present that how the seals can be multi-purpose. And then there's of course plenty of information in this webinar. So if there are any questions, any comments regarding that, don't hesitate to contact me. Check our website, check out my other articles regarding these, and visit our booth in exhibitions coming up in the autumn. So don't hesitate to contact us.